Hello, welcome to my YouTube channel. In this video, we're going to look at a second part of this question where we have to solve the differential equation and obtain an expression for t in terms of h and capital H. So here, as you remember, we have proved in the previous video. So this was our proof. So now we need to solve this differential equation. So the method we learned for separable method is, so we will separate the variables. And then here we need to integrate it. So once we integrate this, so it will become h to the power 5 by 2 over 5 by 2 is equal to negative a t plus the constant c. Okay, so here you can see in the question it says at time t is equal to 0. So the initial conditions are given, the water and the depth of the water is h. So when t is 0, H is capital H. So this is 2 over 5, h to the power 5 by 2 is equal to 0 plus c. So which means c is equal to 2 by 5 h to the power of 5 by 2. So that means this equation will become 2 by 5 h to the power of 5 by 2 is equal to negative at plus 2 by 5 h to the power of 5 by 2. Then here we have another condition given, the tank becomes empty when t is equal to 60. So when t is 60, so the height will become 0. So now when we will use this initial condition, so here we can see this part will be 0. So negative at plus 2 by 5 h to the power of 5 by 2, and here for t we need to replace 60. So once we simplify this, so a times 60 is equal to 2 by 5 h to the power of 5 by 2. So from here if we simplify, so a will be equal to 1 over 50 150 times h to the power of 5 by 2. So that means this equation will become 2 by 5 h to the power of 5 by 2 is equal to negative 1 over 150 h to the power of 5 by 2 t plus 2 by 5 h to the power of 5 by 2. Okay, so we come up with this result, but it says obtain an expression for t in terms of h and capital H. So that means we have to simplify this further. So let's get some space here. So now from here we need to make t the subject. So what we can do here, I'll bring this to the other side and this to the other side. So this will become 1 over 150 h to the power of 5 by 2 times t is equal to 2 by 5 h to the power 5 by 2 minus 2 by 5 h to the power of 5 by 2. So if you can see here throughout, 5 can be cancelled out, so this 5 5 and then this will become 30. So 1 over 30 h to the power 5 by 2 times t is equal to, from here we can have 2 as a common, so we will left over with h to the power 5 by 2 minus small h to the power 5 by 2. So when we multiply this 30 to the other side, so from here we can get t is equal to 60 times h to the power 5 by 2 minus h to the power 5 by 2 over, this will divide on this side. So now once we simplify further, so t will be equal to 60 times Since this is divisible by both of them, so if we divide here, h to the power 5 by 2 over h to the power 5 by 2 minus h to the power 5 by 2 over capital H to the power 5 by 2. So from here t will be equal to 60 times 1 minus h over capital H whole to the power of 5 by 2. So this is the expression for t in terms of h and capital H. Okay, so in the third part it says find the time at which the depth reaches half h. So which means depth is h, so h reaches at half of h. So in this equation, if we replace small h by capital half h, so then from here we can see h and h is going to cancel out, so this will become 60 times 1 minus half to the power of 5 by 2, and once we simplify this one, so this will be 49.4. So the time is 49.4 when the height or the depth reaches at half of it. Hope this is clear to you. Thanks for watching.